So now we are into the measure phase, and what we had done in the measure phase, we'll do a quick recap of measure phase also. Whatever we have done in the define phase, we understood the process as a high level. Now in the measure phase, the time comes we need to collect the data. And we started with understanding how many types of data do we have. We talked about two types of data, the discrete and continuous. While the discrete type of data is something that is counted and can be of categorical type, while the continuous type of data is which has a measuring unit, a measuring scale, and if you break it into small pieces, will still have their relevance. So that's the type of data we can expect when you are collecting it. And then we also prepare data collection plan, and the key characteristics of data collection plan is that it should have it should have an operational definition, the calculation, and should be stable over a period of time, and it should be accurate as well. That is something key that we must remember. So while we are doing the data entire collection, we are talking about a sample coming from a population. We talked that sample should be representative, it should be random and stratified. Representative means that it should represent the entire population characteristics, and should be stratified. Stratified means that we break the entire population into various characteristics and categories, and we collect data from each of random data. We collect random data from each of those stratified factor. So our sample becomes stratified random sample, and that represents the population as much as possible. So that's the sample we collect, and this sample is very important because the entire analysis is based on this sample. Once we've collected the sample, which is a data, we then try to do some statistics on this data, which we call as the basic statistics. We understand the basic this entire data from two point of view. One is the central tendency of the process, and one is the variation in the process. Central tendency focuses on two things, the mean and median. That's how we represent central tendency. Now mean can be mean is the average, which talks about where is a process balanced at or the centered at. If there is a lot of variation in the process, then mean cannot be the right process performance indicator or the right center. In that case, we talk about median as a process center. So we need to be very careful while we talk about mean and median, what should be the center of the process. Then we talk about understanding variation in a process. Typically we use range as a variation, but then range is used for small data set, but range does not tell you what is the spread of the process. So instead of that, we use standard deviation. That really can help us and tell on an average a data point how far it is from the mean. That's what the standard deviation tells us. So when the data is equally spread in the process, when the variation is equal in the process, then standard deviation becomes a very good understanding of the variation in a process. So the lower the standard deviation, lesser variation in the process, and better we meet the customer expectation. And then we talk about understanding these numbers through some graphs. Basically visualize the entire process. So for that we use certain graphs like histogram. We started with histogram talks about how the data is distributed, how much variation is in the process, where is the process centered at, and what is the shape of the process. So all these things we get to know through histogram, a very important tool. Then we talked about the scatter plot, which tells us the relationship between an independent variable x and dependent variable y here. How are these two related with each other? And we can see a correlation, a strong correlation, positive correlation, strong negative correlation. But always remember, in statistics, correlation is not the causation. However, when x is going up, y may also be going up, or y may be going down proportionately, but that does not mean that this x is causing y. There may be some other factor. That's what we need to figure out, but it's only giving you an indication of what might be happening. It might give you a trend but may not tell you the future here. Then we talked about another graphical method called as box plot, which helps you to understand how the entire data is spread. It divides data into 4 equal quartiles, so each divided into 4 quartiles, and it tells you 5 things about a process: the minimum data point, the quartile 1, the median, quartile 3, and then it tells you the last point. And there are whiskers. It also helps you to find the outliers in a process. That's how box plot helps you. Box plot is also useful when you have to compare multiple set of data. You can understand how they are spread. And then at the end we talked about Pareto chart. Pareto chart helps us to prioritize the entire process. It talks about the 80-20 principle. What are those 20% issues because of which we have the 80% problem in the process? So that can really help us to visualize that thing. That 80% issues that is causing the problem, we can actually visualize it using the Pareto chart. So that's how we visualize the entire process. And once we have visualized the entire process, then we talk about a detailed level of process mapping. We talked about process mapping in defined phase at a very low level. Now in the measure phase, we do a very detailed process mapping. We talked about tools like activity chart, which is nothing but a flow chart. A flow chart, we talked about certain symbols like decision making box, square, rhombus and everything, and through that we understand how the information is flowing from one point to another point. But the drawback is we really do not have people, function, businesses here, so we do not know who is doing what. So this problem we can solve using another process mapping method called as swim lane type of diagram. Swim lane has various lanes dedicated to each function, person or a team in which the process happens within the team or a function. So swim lane does the same thing a process flow chart does, but how it does is through each person we can see, through each lane we can see how different functions interact with each other. And it tells us a lot of information like what is total lead time, how many handoff are there, how many decision making steps are there, which is the fastest lane, which is the slowest lane, and so on. So this is a very good information we get from swim lane. But then we also would like to understand the process steps that we are doing, how many of them add value to the customer, how many of them don't add value to the customer. This information we understand through another method called as another type of very widely used, accepted and effective method called as value stream map. So value stream map as a method helps us to understand what is the value added step for customer, what is a business value added step for the customer, what is a non-value added step for the customer. Value added step for the customer is for which customer is ready to pay or ready to wait. Business value added customer can be compliance, law, policy related steps. Customer may not care but business need it. And then third is non-value added step. Neither the business nor the customer need it. How do we find what are the non-valued steps? For that we talked about 7 type of waste, also called as muda in Japanese. There are 7 type of waste summarized as TIMWOOD, TIMWOOD: transportation, inventory, motion, waiting, overproduction, overprocessing, and D for defects or the rework. These 7 type of waste we look at when we talk about these waste. These are all non-value added. We have to identify them and eliminate them in a process. When we are doing a value stream map or a swim lane diagram, we prepare the as is process, the current state. We also prepare a future state of the process as well. Once we have identified a lot of waste and so on, then we also would like to understand how much we are able to meet the customer's requirement, and for that we do the capability study, and there we calculate the defect per million opportunity as a metric that help us to understand what is the sigma level of this process. There we calculate certain, there we need some information like how many defects are there, how many opportunities are there in each unit, how many units are there, and then how many opportunities are there, what is the DPU, and then we calculate DPMO, and then we then we calculate the sigma level using the DPMO. Higher the sigma level, better the process will be. But if you do not have, typically all the processes in the world operate around 3.5 sigma, and that's where you can find yourself as well. But that's the as is the current state of the process. And then at the end we have the measure phase, a toll gate, wherein we talked about all these things that we just discussed that you should have done as part of the measure phase as a toll gate. The questions are asked from the sponsor and the black belt or your coach on all these aspects. Have you collected a sample? What data did you collect? Did you do a process mapping? Did you do a capability study or not? And that's where the measure phase gets over, and that is when we move to the analyze phase. And now as part of the analyze phase, what we have to do is we have to identify the root causes for all the problems that we identified in the measure phase. Like we identified the turnaround time is very high, we identified the average or the median of the process is very high, we identified the standard deviation is very high, we identified the DPMO is very high, sigma level is less. So all these issues that we identified in the measure phase, also we have identified there's a lot of waste in the process. So these issues that we identified in the measure phase, we have to find why are they happening in the process. And for this, in the analyze phase, we'll use certain methods to find the root causes of all these issues, and that's what we are going to do in the analyze phase. So thank you for watching. This is Shivendra Sharma here.